All right. So today we're just going to be looking at some additional examples. No new notes in terms of new theorems or new vocabulary today, but we're going to take some of the problems that you've already done and move them up a notch. For example, this first one. If YR is 16, and AR is 24, and they want us to find the length of KY. Now, the wrong thing to do would be to assume that those two are the same length. They are in fact not the same length. KR is longer than AR is. But the idea that I told you guys about earlier in this unit is that it's going to come up a lot that if you don't have a right triangle, you're going to make a right triangle. So we're going to draw a radius to this point of tangency, and that's going to make a right angle. And at first, you may think that that's not very helpful because I still only have one whole side of the triangle. But here's what we're going to do. I'm going to call this distance R because it's a radius. I'm going to say that this distance is also R because it's a radius. So this whole side is R plus 16. Now we have all the sides either in terms of a number or in terms of R. So I can do the Pythagorean theorem. It's going to be a little bit different than we've done before though. We've got R squared plus 24 squared is equal to R plus 16 squared. Peter, you okay? Yeah, man, he's out. You okay? All right, so here we'll have R squared plus 24 squared. You can use your calculator for that if you don't know it. It's 576. And when we square something, it says multiply it times itself. So we're going to multiply R plus 16 times R plus 16. On the left, there's nothing we can do to make that any nicer than it already is, or any simpler. On the right side, when you were in Algebra 1, you may have called it FOIL, but it's the distributive property. We're just going to distribute the R, and then we're going to distribute the 16. So when we distribute the R, we'll have R times R, and then R times 16. R times R is R squared. R times 16 is 16R. Then we'll distribute the 16. 16 times R and 16 times 16. Well, 16 times R is another 16R. And 16 times 16 is 256. At this point, this is as messy as this is going to get. At this point, it suddenly gets a lot nicer because I can subtract off an R squared from both sides and all the R squareds are gone now. And I'm going to go ahead and subtract the 256 from both sides. And when we do that, we get 320 is equal to 16R plus 16R, which is 32R. And I just divide both sides by 32. and I get that the radius is r and ky was one of the radii. So for those of you who occasionally tell me that I was a lot better at algebra, well, this is your chance to show your algebra skills. All right, let's take a look at this next one. So the length of JA is 3x plus 7. The length of AM is 5x minus 11. The length of ME is 4y plus 8. And the length of SE is 2y plus 12. Okay, one of our theorem tells us that when we have segments drawn from an exterior point to 2 points of tangency, that those two segments are congruent to one another. So JA and MA are congruent to one another. And over here, SE and ME are congruent to one another. So we know that 3x plus 7 is equal to 5x minus 11. I'm going to do 2 steps at once. I'm going to add the 11 and subtract the 3x. So they get 2x is 18. So x is 9. And to help me find AE, I'm going to go ahead and substitute into this. 5 times 9 minus 11 is 45 minus 11 is 34. Then I'll do the same thing here. These two are congruent to one another, so the lengths are equal. So it'd be 2y plus 12 is equal to 4y plus 8. Subtract the 8, subtract the 2y, divide, and we get y as 2. So this would be 4 times 2 plus 8. 8 and 8 is 16. So then AE will be 34 plus 16 is 50. All right, for this next example, you're going to get lots of problems that look like these. It tells you the measure of arc LD is 120. And the distance from L to D is 40. And you want to find the length from T to D. One of the themes that keeps coming up in this unit is that if you don't have a right triangle, make a right triangle. What I'm going to do is I'm going to draw from the center, T, perpendicular to the chord. That then is going to bisect the chord, so each of these pieces is 20. And it also bisects the arc, so each of these arcs is 60. We've got a right triangle, which is nice, but we only know one side of it, which isn't quite enough. But since this arc is 60, its central angle is also 60. So now I've got a 30, 60, 90 triangle. And we haven't done one this ugly in a while, so remember that the short leg is across from the 30-degree angle, so I'll call this S. The long leg is the short leg times the square root of 3, so that's S square roots of 3. And the hypotenuse is twice the short leg, it's 2s. So I've got s square roots of 3 is equal to 20. I need to solve that for s, so I'll divide both sides by the square root of 3. That would be fine, except we don't leave square roots in the denominator if we can help it. So we'll multiply by the square root of 3 over the square root of 3. So that's 20 square roots of 3 over 3. Since 3 won't divide evenly into 20, I'll just leave it as a fraction. And then TD is 2s. So that'll be 2 times 20 square roots of 3 over 3. 2 times 20 square roots of 3 over 3 is 40 square roots of 3 over 3. You don't multiply top and bottom by 2 because it's 2 over 1, not 2 over 2. All right, last one. Here we're given the diameter ns is 40, so that means that both radii are 20. We're given the length of ry is 8. And on this one, as on several of the other ones, we don't have a right triangle yet, so I'm going to join t to y. And since yt is a radius, its length is also 20. So now we can do the Pythagorean theorem to find the length of tr. Tr squared plus 8 squared is equal to 20 squared. So tr squared plus 64 is equal to 400. Subtracting and taking the square root, tr will be the square root of 336, which is bound to simplify. It's really easy to divide it by 3, so I'm going to start there. 112 isn't divisible by 3, though. Remember, the trick for that is add the 1, 1, and 2. That's 4. That's not divisible by 3, so this number is not divisible by 3 either. So I'll change over to 2. That's 56. 2 goes into 56 28 times. 2 goes into 28 14 times. 2 goes into 14 7 times. And 7 goes into 7 once. So remember, we have the square root of 2 times the square root of 2, which is 2. We've got another square root of 2 times the square root of 2, which is 2. And we still have a square root of 3 and a square root of 7 that never got matched up with anything. So that's 4 square roots of 21. Any questions about that? All right, just wanted to do some of those because those were some of the harder examples. You will have some like this on your homework tonight. It's a worksheet, but not all of them are this difficult. Some of them are more straightforward.